Hello, this is Randall Root, and in this video we're going to take a look at a demo on constraints, indexes, views, and stored procedures and how they represent common database options when you're designing and creating a database. The first topic is constraints. Constraints allow you to restrict values in a column or sometimes in a set of columns. And to demonstrate this, I'm going to go through and create a new database. I call it Common Options Demo Database. And I'll go ahead and focus on it. Now, in the industry, they represent, or excuse me, they talk about 4 different categories or types of data integrity. And these are restrictions, again, to keep your data clean so that they are consistent with each other, the values are consistent with each other, and they hold their integrity. They can't be misrepresented. So the categories or types are domain, entity, referential, and user defined. And what happens is that entity refers to protecting the table as a whole. More specifically, a individual row in the table. So you should be able to determine to find a particular row in each table. Entity integrity protects that. Domain integrity protects the values in a column or set of columns. Referential integrity protects values that are between columns being referenced with each other. And then user-defined integrity just covers anything else that that you may need specifically for your company, your business, your department, whatever. So these categories, you'll hear about them or read about them when you're looking up things about constraints. But the tools that you use to accomplish that in SQL Server are these. Primary keys, and here's a demo table. I'm going to have a single column here with a primary key, another column with a unique constraint. So this is a primary key constraint, this is a unique constraint. Both of those are tools for enforcing data integrity. A check constraint, a foreign key constraint, a default constraint, and a not null constraint. These last two, there's some argument in Microsoft's documentation about whether or not they are constraints. In general, the default constraint comes out as being represented as indeed a constraint. The not null sometimes does and does not. I would say, I don't know, it's about a 50-50 chance in the documentation whether they'll call it a constraint or not. Default is more like about 70% they'll call it a constraint. Odd thing is that the default doesn't restrict a value. Not null does. Constraining something seems like a restriction. So I'm kind of surprised at this, but what you can do? What can you do? So anyway, don't worry about it. Here's the deal. Just consider all of these as the constraint tools that you have at your disposal and move on with your life. It's not all that important unless you're taking some kind of exam and they really want you to focus on what their particular labeling of the month is. Now, if I make this table up, it will have a representation of all the standard tools that are built into Microsoft SQL Server. It doesn't, of course, show you a stored procedure or a trigger in this example, but that's all right. Those are custom tools, and I'll talk about them later. Now, the constraints, when they're added, you can get information about a table and see what kind of constraints are on it using a stored procedure Microsoft made years ago called SP Help. SP_help, or people just pronounce it usually SP Help. If you run it, it will show you all kinds of information about the table. But one of the things it includes, let me see if I can get this a little bigger for us. I'm going to get just the right spot. There we go. Well, one of the things it includes is information about the columns and any indexes. And if I go a little further down, the constraints. And you can see that under constraint, the default one is indeed listed. The null entries are not, which is, yeah, again, one of the things you just have to kind of get over. It's no big deal. I didn't provide a constraint name, so when you don't, Microsoft provides names for your constraints. They look a little funky, but you know, most of the time you don't care. And you can see that a check constraint has been defined, a foreign key constraint has been defined, primary key constraint and unique constraint, as well as, again, the default constraint are all here. The foreign key constraint is kind of an odd entry. It takes up 2 rows to display its information. I'll talk more about that also in just a second. So let me zoom back in here and we'll take a look at this information. Let's see. I may have lost my video. Give me just a second. Nope, I'm good. Okay. Just want to make sure that you guys can see what's on my screen. So in the case of the check constraint, you can see here on the side where it says the column 3 has to be greater than the value 0. This gives you information about it. The next one is default constraint. I'm not going to pan over there because I want to use my little cursor. It shows you that the default value is 0. The next one down was the foreign key constraint, and what it says is that column 4 references, and I'll have to actually unzoom here, give me a second, column 2. And then the primary key is on column 1 and the unique constraint on column 2. So this just gives you quite a nice little overview of what's going on on that particular table. And again, the stored procedure built in by Microsoft is called SP Help. It gives you more information perhaps than you really want. If you just want the constraint, Microsoft added something called SP Help Constraint. You gotta admit it's not a bad name. And what it does, it just gives you the same information, but without the additional things like the column names and data types, etc. One thing about SP Help is that the column names are listed. Nullability is listed here too. And again, although in about 50% of Microsoft documentation they say it's a constraint, it doesn't show up in the constraint section of the report here, but it does show up in this first part. We have the column listing and their data types. So good to know. Later on, Microsoft added additional views that gave you information about specific constraints. Like here, it shows me the default constraints in the database I'm currently focused on. I'm currently focused on this new database I made. So all those, all the default constraints in that database would show. There's only one right now. Check constraints and key constraints. You notice that the primary key and unique key constraints show up. Now, when you make it, when you declare code or SQL expressions to cause, boy, I'm really mangling that. When you go through and you create code with custom expressions or custom script text that you want to run, Microsoft has a view that will show you that code. And what I mean by that, again, because I'm kind of mangling it, is this. I had some specific code as an expression when I made my check constraint. Syscomments shows me that expression or code. It is also the place where if I make a stored procedure or a trigger, view, or function, I will see the text there as well. And that's because it saves my actual code that I wrote. And Microsoft then later on utilizes that code. Actually, the code they use is the compiled text. They convert it over to binary format. Um, so specifically, you don't really need the text here, although Microsoft doesn't recommend you delete it just to obscure your values. This is not encrypted. It is obscure, but this is indeed what really the system needs. It doesn't need the text stuff. Just for the humans. Let's So that's how you make constraints. This is the syntax for making the constraints, and that's how you get information about the constraints. But let's go ahead and start breaking down what the constraints do for you. So here's an example. I have a table called products, and I have a typical design here where I have a product ID and a product name, and a supplier ID, and a unit price, and a units in stock, all the standard stuff. My data types are simple. An integer for the ID, in Unicode varchar for the Unicode string, excuse me, for the product name, integer for the supplier ID. I'm using the money data type for unit price and just a small integer, which gives me 32,000 possible values, negative and positive. So that should be enough for units in stock. And then the specification of null or not null is designated by just right in your column listing, putting in the words null or not null. Now, if you forget to put that in, the default behavior is null. It's probably a good idea when you type out your code to actually be explicit. So it's not hard to do, just put it in there. The default constraint and the null specification can both go on the same line. You'll notice that even though they represent two different constraints, if you would, you don't put a comma separated value to identify them. The commas identify one column for the other. So you just put a space there and you start listing the other. So an example would be if I had yet another constraint here, like a check constraint, I would do the same thing. I would just go through and say unit price has to be greater than 0. So I wouldn't put a comma or anything in there, just a space to separate the various different constraints I'm stacking on. If you make a constraint like a default constraint, and again, you don't give it a name, Microsoft generates one for you. We saw the names were a little funky, but most of the time you just don't care. If you would like them to look a little bit more professional, easy enough to do, just use the word constraint, provide a name before you specify that you want a default constraint. So that's very, very simple. Identity is the auto number feature, and although people think that it's a constraint, and I can see why they would, it's not classified as a constraint. It is a feature that allows you to automatically add values to the column. Now, to me, that sounds a whole lot like a default constraint. Default constraint says that if you don't specify a value, you will get a value, in this case 0. However, the identity, if you don't specify a value, you will get a value of 1 in this case, and then the next time you add a row, 2, and next time 3, next time 4. The way the identity works is you can put a starting number, let's say I put it at 100, and then the increment. Let's say I put 10. And if you do that, the first row of the table will be 100, next row will be 110, 120, 130. Again, it sounds to me like an automated default constraint, but they don't classify it as that, so what can you do? Just kind of go with the flow. I think maybe some of the reasons for this is industry standards, but it's a loose argument. Anyway, and there's nothing stopping you from adding other features to that column. A very common one that you would add, as we'll see a little later on, is a primary key constraint, which forces unique values. right now, identity will not force unique values. However, it automatically adds the values in for you, 1, 2, 3, and as such, you basically end up having unique values, well, by default. However, it doesn't enforce unique values, so you probably want to put something on there that actually checks to make sure the values are unique. It would seem improbable that you would get a duplicate value, but here's the reason why. If you try to manually put a value inside an identity column, what happens is it actually gives you an error message. It says you cannot do this unless you actually turn the feature temporarily off. Or I should say you turn a feature that allows you to do an insert temporarily on. The feature is the let's see, auto identity insert. No, identity insert. And if you try to put a value in manually, it'll come up with an error message and tell you, hey, you got to turn this identity insert feature on, slide the new value in, and then turn it back off again so that the auto number keeps incrementing. When you do that, though, you could at that point introduce manually a duplicate value if you didn't have some way to force a restriction that things must be unique. So identity, again, is not a constraint. It does not enforce any rules other than the fact that it does not allow you to insert your own values unless you flip the little switch allowing you to manually insert something. It is much more like a default constraint, but it's not considered a true constraint. Hopefully that makes sense. Now, if I go through and I make this table up, I can look at the constraints, and I can see in here that I've got the two default constraints. The default constraints again have a made-up name by Microsoft from line 55. That's what they come up with, or a specific name that I just made up. And I think that looks a little bit more professional, but it's certainly not a requirement, so nice to have. If I just go through and say system constraints, is that right? It doesn't look right. From check constraints. You look at sys constraints this way. It's a little hard to read. I guess that's why they want me to use the other one. These ID identifiers, every object you make has an identifier. If you don't want to look up what the identifier is, you can use this function called object ID, put in the actual name of the object, and it will generate the ID for you. Or it'll look up the ID for you, I should say. Okay, let me go back here. I can get the individual constraints. I can't get the one. Let me think here. Well, how about we just do SP help? I think that's a good idea. And it's products. Okay, so what I want to show you here is the only constraints shown on here are the default constraints. You can see that the identity option is not shown here as a constraint. It does have its own little special section up here. The seed is the number you start off with. The increment, of course, is what it increments by. Not for replication is an advanced feature when you're replicating data using Microsoft's built-in replication. Nothing to worry about at this point. So that's a default constraint, and the key things, the takeaway is this. Identity is the auto number feature. It's close to a default constraint, but it's not really classified as a default constraint. It automatically adds numbers in for you, or values in for you, like a default constraint is. But it also automatically keeps doing that, and a default constraint doesn't have that capability. It's just you tell it what kind of value, either numeric value, character value, whatever it is that you want to put in there by default. Now, by the way, if it is character data, you make sure that you use quotes. And in SQL, you have to use SQL quotes, or single quotes. SQL quotes. Well, I can't talk this morning. So, for example, if I put in a default, can't type either, A-U-L-T, and I want to put a default constraint for product name of, like, I don't know, N-A. If I did that, I'd have to use single quotes to accomplish that goal, not double quotes. That's important. And for those who are new to programming in SQL, it seems a little different than what you're used to. As far as the null constraints, again, you just put in null or not null after the data type. If you do not specify nullability, it will assume you want to allow nulls. Next on the list, primary key constraints. Primary key constraints allow you to restrict possible values in a column or columns. And their main feature is that they restrict values to be unique. In addition to that, they also indicate which column or set of columns you've chosen to use as the primary key. So you can have a set of columns you've chosen to be the primary key of your table without actually having a primary key constraint. But at that point, you're on the honor system, so it's recommended that you go through and put a primary key constraint to enforce the rules that have just hoped that people will behave. You know, you can actually put in, like I showed in the first demo table, the word primary key right after the column name. That's one option. Another option is, after you list out all of your columns indicating your data type and nullability, is to go through and create all the constraints after the column listing. Somebody figured that we needed a name for that, so they called that a table level constraint. And if you see that in documentation, you may be thinking there's got to be some additional features or some other reason that that name exists other than the fact that it's done after the column listing, but there's not. It's exactly the same thing. Whether you do it, you indicate that you want a primary key at the column level or after the fact in the table definition, after you've listed all the columns, makes no difference, runs exactly the same way. So don't let the name lead you to believe, like it does so many, that there's some additional significance. There is not. So I'm just saying that I want a new constraint, primary key constraint, excuse me, this is going to be my new name, primary key constraint. I want it to use a clustered index. Clustered index, by the way, is the default. It means that the actual table itself is going to be sequentially sorted based on this particular column or columns. If you don't make it clustered, if you don't indicate it's clustered, it will actually be clustered anyway, so you don't specifically have to type that in. If you wanted to make it non-clustered, you could. This would actually copy the data into another space on the hard drive for that one column and sequentially organize that column in its separate space. I don't want to get into indexing too much here, but anyway, most of the time you're just fine leaving it as it is. Again, one last thing, there is no significant difference between putting it up here or putting it down here. It just makes no difference. One is considered a column level constraint, one is considered a table level constraint, but the name is really meaningless. Now let's talk about indexes and how they relate to tables. Basically, when you make a table, what happens is the data is placed in the actual structure on the hard drive in these little 8 kilobyte chunks. So if you open up the file in Notepad, you'll see that the data file has some text that shows up. Other parts will just be kind of a squiggly mess that indicates that the data is really stored in a binary fashion. And what they do is they logically chop up that data file into 8 kilobyte chunks. And those chunks, those 8 kilobyte chunks, are not sequentially organized when you first create the table. So the data inside there is what they call a heap. It's unstructured data. So if I create a new table like this phone list table and insert some data, because I inserted it as values 1, 2, and 3, it looks like it's sequentially organized. However, it's not. It's well, I guess it is sequential. The problem is it doesn't maintain that. So if I were to go through and delete one row of data from the table, so now we have row 2 missing, and insert a new row, ID 4, you can see that it used up that empty space that was available to it when I deleted the second row. So what happens is that the data page just gets marked as that row of can be reused, and that's exactly what it did. It doesn't maintain its sequential structure. Now that is what a table's pages look like when you first make them. However, if you add a clustered index on that particular set of data pages on the table, what happens is it does indeed maintain the sequential order. So if I go through and add a clustered index on the phone list table, specifically on the ID column, what's going to occur is that now it will not only reorder everything into a sequential order, but it will maintain that. And often you really kind of want that, because if the system goes through and you say, hey, give me all the information about the customer who is ID number 4, or let's say 3. Well, the system has to start looking for the IDs, and they'll look at 1, they'll look at 3, but they won't go to 4 because they'll know that it's sequentially organized and there's no need to go any further. In a heap, it has to scan through everything because it never knows where the last 3 may show up. In this case, we have 3 rows. It wouldn't make any difference. But if we had 3 million rows, it would make a big difference. So most of the time, you probably want to have a clustered index on a table. And if you remember from the previous section here, primary key constraints, which are usually on an ID column anyway, by default have a clustered index on them. And that's why most of the time when you write your application code, you'll probably want to, in the where clause, you want to use a where clause that says, give me all the information about a customer where the customer ID is such and such. Non-cluster indexes are also kind of handy, but what they do is they make a copy of the data from a column, and they put the copy in its own set of 8 kilobyte data pages, these little data pages. And then what they do is they have a little reference value that looks up where the original value is. So it's kind of handy. Let's say I have a name column in the phone list. I put a non-clustered index on the name column. Well, now, in addition to the data pages that make up the phone list table, there's also this invisible set of data pages specifically holding names in sequential order. If you remember the results, Bob, Joe, and Tim, actually in this case they are sequential. I guess I should change that around. But the deal is that this data here will be held separately, and it will be maintained in sequential order, so that if you say, give me the information about Joe Harris, it knows when it gets down to J's, if it once it runs out of JEO for Joe Harris, it won't need to look any further for data because it knows that this is maintained sequentially. Now it's maintained in a separate spot, so it has to have a lookup going back to the original table so it can get the data, unless you only ask specifically for the data in the non-clustered index. This is what's called as a covered query or covering index. If you do a select statement and say give me all the column data, it doesn't need to use, it uses the actual data pages of the table itself. If, however, you say that you only want the name column, there's no need to use the data pages of the table itself. You can get all the information you need right from the non-clustered index. Now the advantage is this. Let's say you have 1,000,000 rows. You have 3, 5, 15 columns. Well, that data takes up a lot more space with those additional columns in all those rows than just a single column with 1,000,000 rows. So it's going to be faster when the data gets returned if you use the non-clustered index copy to resolve the query for you. Let's see here. There's a feature I can turn on. This is called the the actual execution plan. And when you turn that feature on, it will give you a visual diagram indicating how the query was resolved. So the first query says select everything, select all from the phone list table. And what it does is it scans through the clustered index. The clustered index, remember, is clustered is the actual table itself. It scans through all the little pages of the clustered index. Versus where I'm asking just specifically for the name, that one I can use the non-cluster index because it has everything I need to resolve the query. And again, it wouldn't make any difference here. The performance difference is the same. There's only 3 rows of data. But if you have millions of rows of data, it can have a large impact. So what developers often do is, or excuse me, administrators often do, is they'll go through and look at your applications that you build as a developer, and then they will say, okay, the web page or whatever you've made needs to show a table of values or charts or product listing or whatever of these 3 or 4 columns. And what they'll do is they'll make a non-clustered index on just those columns that are necessary to be displayed in your application. Now, SQL automatically will adjust and use the non-cluster index, which will increase the performance of your web application. So it's handy to do. If you are the developer of the database as well as the developer of the application, well, it's going to be up to you to think about what columns your application uses and then put a non-clustered index on those columns. So if you ask for everything, it'll just use the table itself, the clustered index. It's not going to really help you performance-wise to add index. If you do something like this, though, if you add an order by clause where you say, hey, show me the results in my web page where the product listing shown in a particular order or customer listing shown in a particular order, the fact that the data is already ordered by ID makes the query faster, more responsive. Same thing is kind of true when I go through and I say I want to display the phone listing, everything based on the name. Now I'm getting all the columns from the table, but what it can do is it could go through, if I had enough data, use the non-cluster index to find the sort order of everything, and then go back and pull out the values from the clustered index. Keep doing this until you get all the results, and then pass it on. And this would, in large data sets, be helpful, or at least somewhat helpful, as far as getting better performance for your web application. If I'm looking for a specific ID, obviously, being able to find it when you know you get to the 4s. If you get to 5, it's no need to continue. The where clause is almost always something that you want to look at as far as tuning, because you're trying to filter out values. Having a index on the ID column is going to help with that. Same thing is true of if I'm looking for a specific name or specific string value or number in a non-cluster index. Very helpful with that, resolving that query. If I'm only looking, I'm getting all columns from there, but I'm doing the where clause lookup. If I'm only getting a particular column, as I've shown you, I can use the non-cluster index, which is smaller in its size on the hard drive, because it only has the columns that you chose to be part of the non-cluster index. And that will be helpful also. It'll, make my web pages more responsive. The lookup value between the actual table, so let's say that this represents the actual table with its 3 columns. 1, 2. And then you make a non-clustered index on this name column. So it makes a non-clustered index in a separate spot on the hard drive. It's actually in the same database file, but internally the database file is chopped up into these little data pages. And it puts all the names over here. So if I do select name from phone list, it doesn't pull the data from here, which is much bigger. It pulls it from here, which is much smaller. But in order for it to be useful, it needs a cross-reference between these names and the actual table for things like look for Joe Harris, but give me all the information. With this query, 179, it looks for Joe Harris, finds Joe Harris, and then it says, okay, Joe Harris is here, and if you want to get all the columns, you look it up by going over here. And the way they do that is they add on a reference column. It turns out that the reference column will be the ID column, the column that has the clustered index on there. So they call this column, that's supposed to be a C, not a very good one, the clustered index key. And that's what they use to cross-reference the name in the non-cluster index or whatever columns you've chosen. Well, because non-cluster indexes have the key column as well as the actual chosen column, if you ask for the ID and the name, everything I need is actually in this non-cluster index. So if you know what the key value is, you can see it just used the non-cluster index because it had both columns in there, and I get my results. And once again, this can increase performance. This is another example of a covered index. Now, there's much more details, but the long and the short of it is that every table should have a clustered index on it in general, most every table, and that you probably want to include non-cluster indexes for tuning purposes. And the way it usually gets used is this. If you have columns that you display on web pages, that would just be a subset of the columns in one or more tables. You put a non-clustered index on that subset of column, and it will be covered. That index will be covering. That index will help you to retrieve the data in a covered query. So the index will be covering all the data you need to resolve your query, and will speed up your web pages. Hopefully that makes sense. Next, on to views. Views are just save select statements. They act as an abstraction layer. Basically, you put a select statement together. Let's see, what database? Oh, I should be using Northwind. Okay. Put a select statement together. This is combining data from the orders table and the customers table. And then you create a view that captures your save select statement. You just say create view, you make up a name, and then after the as keyword, you put in whatever select statement you want to save. Once you've done that, if you run the code select all from the view, it will show you the data. Now, views do not have separate data pages, so they do not provide increased performance. They they don't ever have any actual data pages on the hard drive. They're just save select statements. So if you want to increase performance, you use indexing for that. If, however, you want the convenience or the flexibility of adding a abstraction layer, views are very handy for that. And it's recommended that you never program directly to the table itself when you're making your applications. Instead, you always program to the view or a stored procedure, as we'll see next. Now, I'm going to talk more about these next lesson, so I'm going to just kind of go over this really lightly. Syscommits holds that definition for the view, just like we saw with the check constraint and the default constraint. It's actually held right here. Once again, it's this compiled text that really gets used, but for the human, you can actually see the code that somebody wrote. So if you want to look at, let's say I have a stored procedure like sp_help, which I believe is in the master database. I could actually go through and look at Microsoft's definition and see how they wrote the code. I wouldn't call it exactly open source, but it's kind of interesting that you can see their code, drill down into it. Of course, it's a little bit messy seeing it that way, so Microsoft made another stored procedure that is helpful. It's called sp_help text, and what it does is it shows you the text as it was laid out with all the carriage returns by the author. And once again, this is kind of handy. It certainly is easier to read. Help when it's typed out like that. These views are very simple. This is a stored procedure. sp_help text is a stored procedure. And as you can see here, you can have many hundreds or even thousands of lines of code. This one's only about 230. But whether it's a view or a stored procedure, sp_help text will show you the text in both of those objects. Stored procedures like sp_help are just as simple as making a view. You just put in some code that you want to save, and you say create proc instead of create view, and give it a name. Once you've done that, then you can go through and execute it a couple different ways. You can type in the word execute, the name of the stored procedure. You just type the abbreviated version. Or you can just go ahead and execute the name of the stored procedure by itself, and most of the time it'll figure that out. There are times where that doesn't work, and here's why. When I went up here and I put in sp_help, it didn't execute sp_help. It used it as an argument. So when you do this, even if it's on a separate line, it assumes that what you're trying to do is you're trying to pass this in as an argument for that stored procedure. So in other words, if I were to go through here and run both of these, it would assume that this would be the argument for that first stored procedure, and as such, it's recommended you actually put in the word execute, either in its full form or its truncated form when you call your code. And it's just considered a best practice. Once again, you can see the information in syscommits and use sp_help text to get the actual text for the stored procedures that you've made. We're going to drill into this next week, in class. So until then, I think we'll just wait on this. And I think that catches us up on the material that we missed. So hopefully this was helpful. And I will look forward to seeing you guys in class. Take care.